In the previous video, while I was explaining force velocity, the video got cut off. So I thought instead of refilming everything, I'm just going to re-explain force velocity. So what force velocity states that, what the graph states that is, depending on the velocity that the muscle cell moves, the amount of force it can output will change. So in other words, the force being output depends on how fast the muscle cell will need to be moved. So if you look in this situation again, a person is holding a weight. If the force of this weight is equal to this position, then we're gonna have in essence zero velocity can be force. And this weight cannot be moved any higher because the amount of force it can output to counteract this weight is only this much. So let's say, for instance, you're thinking, wait, why can't I move it at, let's say, this speed? Well, if you want to move at this speed, the muscle will only be able to output this amount of force. So if this is, let's say, 4 newtons and this is 10 newtons, then you're trying to push a force. You're trying to apply 4 newtons at a speed of, let's say, 8 centimeters a second. Well, that won't happen because you didn't apply enough force, so it's impossible. Or you can look at it the other way. So instead of finding the force to see the speed, you can think about moving it at a speed. So if you were to move this at a speed of, let's say, 2 centimeters a second, it means the maximum amount of force you can apply is this much. That's the maximum you can apply. This is known as concentric because what's happening is the muscles are contracting. So because muscles only apply force through contraction, and their relaxation is what causes them to lengthen, re-lengthen, return to normal position, or even extend even more. But the force in muscles are only contracting forces. So if you want to lift this up, you need some kind of contracting force inside a muscle to lift it up. But you cannot apply it at a speed of this much if the weight really is at this position, if it is at the isometric line. Well, you can say, well, if I'm keeping it up, well, can I pull it down? Well, yes, you can pull it down. And why you can pull it down? It's because you're relaxing the muscle now. To have an eccentric speed in that sense, the velocity will be negative. So the muscle can relax and allow this to drop down. So in other words, it can support a force by moving. If I were to say, let me drop this weight 2 centimeters down a second, let's say at this point, it means I can hold a weight that's this much. Why can I hold a weight that's this much? Because I can support a weight that's this much. I can apply this much force downwards in a sense to hold the weight up. So, sorry, let me restate that. By moving down 2 centimeters a second, I can produce a resisting force of this much. This much weight I can hold if I am moving, if I'm relaxing at that rate. So in other words, when I relax the muscles, I can support a much more weight. And you can see this goes up until it ends, until like the maximum position, where either the muscle cannot move that fast anymore, or that force is just not practical. So yeah, so this is the force velocity. This is the force velocity relationship, and yeah, so it helps explain, especially when you combine it with the force length and velocity. You have a 3D curve which looks something like this. If you've seen a picture, I'm not a good drawer, and it basically comes down like this. It's basically this relationship mixed in with this force length relationship. Usually they disregard the passive because you're only looking at this distance. Because at the passive region, you are going to have some damage can happen.